Hello, students. Welcome to KENE'S Educare, a group of KENE solutions. This is part 5 of lesson number 1, Atoms and Molecules. So, as we are on to part 5 now, we have even completed about atoms in the last part, if you all remember, right? We studied so many things about atom, like what exactly is atom, what are the symbols that we use to represent an atom, what is the exact size of the atom, how big are atoms. So we discussed about atomic radius as well. Then there were so many things that we have discussed with respect to atom, and I hope every one of you are clear with all that concept regarding atoms. Okay, and if you remember, in the last class we even started with discussion on molecules, like what exactly molecules are. We haven't discussed yet in detail about it, but we have studied it, right? So we will be continuing today in this part with more about molecules. But before that, as we do it in all parts, I want each one of you to please revise whatever you have written in your book so that we can start further. Okay, and I hope like every one of you have proper notes with you all, right? Whatever you're taking, like whatever I'm teaching you, you all are taking proper note of it. So I just want you all to revise whatever you have written in your book, and then we will start further. So, like we have started this lesson by discussing about the Indian and the Greek philosophers, right? We discussed on two different Indian philosophers over here. What exactly Maharishi Kannad and Pakuda Katyayama elaborated, and then we discussed about the Greek philosophers, Democritus and Leucippus. Okay, so I just want you all to please go through it once. After this, we discussed more about Democritus, like what exactly he have mentioned, right? So I just want each one of you to please go through the slide as well. Then we discussed on the law of chemical combination, where we have two different law of chemical combination to discuss. One is law of conservation of mass, and the other one is law of constant proportion, right? So this is the activity which is supporting, you can say, this activity is supporting the first law, that is law of conservation of mass, right? Then we discussed on second law that we have, that is law of constant proportion, which we know that has been stated by Proust as in a chemical substance the elements are always present in definite proportion by mass, right? After this we discussed on like who exactly John Dalton was, right? So he had his teaching career, which was started at an early age of 12. Then he became the school principal. He like went to Manchester to teach mathematics, physics, chemistry in college. where he spent most of his time researching and teaching all the students. So, like in 1808, he came up with his atomic theory, which became the turning point in the study of matter, right? After this, we discussed on the six important postulates of Dalton's atomic theory. So I just want each one of you to please go through it once. After this, Dalton's atomic theory, we discussed on what exactly is an atom, right? So we know that the smallest tiny particle of matter, which we cannot divide further, we call that as an atom, right? So we can say that atom is the smallest building block of matter, and we can consider the examples of sodium, hydrogen, oxygen, and we know that atoms are made up of electrons, neutrons, protons, right? So we will be studying about this electrons, neutrons, and protons further. Okay. After that, we will be discussing on like how big are atoms. So we know that atoms are very small, smaller than anything that we can imagine or compare it with it, right? Because a small thing that you have in front of you, okay, that is made up of like millions of atoms when they have been stacked together. That makes like as they have stated that like the sheet of paper in front of you is like been made by millions of atoms when they are totally stacked together, right? And here we have information on like atomic radius. We know atomic radius, and we know atomic radius is measured in nanometers. Okay, so we have like the relative sizes which have been given. So we have the radii along with the examples. So I just want each one of you to please go through it once. So here we have like information given on magnified images of the surfaces, right? So after this we discussed on like what are the modern day symbols of atoms of different elements, right? So here we have different elements like hydrogen, phosphorus, sulfur, silver, platina, gold, and everything has been given over here. So Berzelius suggested that the symbols of elements like they can be made from one or two letters of the name instead of representing it this way, right? So Dalton was the first scientist who had like come up and he was like using the symbols which have been given on the slide. But as I said that after Dalton, Berzelius he came up with naming them with one or two letters of the name of the element. Okay, so I just want each one of you to please go through it once. After this, we discussed on like more examples on it and about the IUPAC system as well, which is again very important. Now, IUPAC stands for International Union of Pure and Applied Chemistry. So I just hope every one of you are going through it. After this, now this was the very important table that we had symbols for some elements, right? So we have some of the elements and symbols which have been given. Uh, so I just want you all to please go through it once. After this, we discussed on atomic mass in detail. So I just want each one of you to please quickly go through it, like what exactly atomic mass is. After this atomic mass, like here we have the like we define the atomic mass as in the concept as AMU, that is atomic mass unit, right? But now instead of writing this AMU, we consider only U. We just write U, which we know it as unified mass, right? And this unified mass is going to be equal to one carbon atom, okay? And we will assign carbon on atomic mass of 1.0 U and oxygen an atomic mass of 1.33 U. Okay, so I just want you all to please go through it once. I hope everyone is going through this slide. After this, we discussed more about it, so I just want each one of you to please go through it. Then after this, these are some of the elements with the atomic masses which have been given. So I just want each one of you to please go through it once. After this, we discussed on how do exactly atoms exist. So I just want each one of you to please go through it once as well. Now this is very important as well, right? After this, we discussed on what is molecule as well, right? So I just want each one of you to please go through it once. I hope everyone is going through it, and you should also be going through, you can say, the examples which have been given, right? So I want you all to please go through that as well. Then we discussed on molecules of elements, so we need to discuss over here, right? So see, the molecules of an element are constituted by the same type of atoms. Okay, so molecules of many elements such as argon, which stands for Ar, helium, He, they are made up of only one atom of the element, right? So for, but this is not the case with most of the non-metals. Okay, for example, a molecule of oxygen consists of two atoms of oxygen, and that is why we know those molecules as diatomic molecule. If it is one, it becomes monoatomic. If it is two, it becomes diatomic, and the example is oxygen, O2. If three atoms of oxygens they unite into a molecule instead of two, we get an ozone, right? So in that case it becomes O3. So the number of atoms constituting a molecule is known as its atomicity. What is atomicity? The number of atom present in, you can say, the number of atom constituting a molecule, we know that as its atomicity. And metals and some other elements like carbon, they're not going to have simple structure. Instead, their structure is going to be very large, and they will have indefinite number of atoms which will be bonded together. So we have some of the atomicity given over here. So the type of the element is non-metal, and the names given are like argon, helium, oxygen, hydrogen, nitrogen, chlorine, phosphorus, and sulfur. Now it's very important that you all are aware of it. Okay, so chlorine is diatomic, you should be knowing that. Then you should be knowing that helium is monoatomic, sulfur is polyatomic. Okay, so I just want each one of you to please go through it. I hope everyone is writing it, but before that, you have to even define what is atomicity, right? So I just want each one of you to please go through it. I hope everyone is going through this statement. So this table also you need to take a note of. You should be knowing the examples of monoatomicity, diatomicity, and you can say tetra and polyatomicity. Okay. Next we have is molecules of compounds. So see, atoms of different elements, they join together in definite proportion to form molecules of compound. What do they form? Molecules of compound. So few examples are been given over here on molecules of compounds, right? So we have different compounds like water, H2O, okay, which is like made by combining the elements as hydrogen and oxygen. Ammonia, which has been like the formula for ammonia is NH3, which has been formed by combining nitrogen and hydrogen, and the ratio is 14 is to 3. Then we have carbon dioxide, which has been formed by carbon and oxygen, and the ratio is 3 is to 8. Okay. I hope everyone is writing the compounds. Then now we have this activity to discuss, activity 3.2. See, refer to table 3.4 for ratio by mass of atom which is present in molecule, and we can refer to table 3.2 for atomic masses of elements. Okay. After doing it, find the ratio by number of atoms of elements in the molecules of compound which has been given in the table 3.4. Okay, and know that the ratio by number of atoms for for a water molecule can be found as follows. So the ratio by number of atom for water is H is to 8. So we know hydrogen is in ratio, uh, you can say 2, and water ka ratio is 1, right? So the ratio becomes 2:1. So here we have the elements as H and O. How it has been calculated, they have shown you that. Okay. So the ratio by mass of hydrogen is like 1 and for oxygen is 8, right? We know that. We know the atomic mass of hydrogen is 1 and that of oxygen is 16. So when we are calculating the mass ratio by the atomic mass, it becomes equal to, like, because we know the ratio by mass is 8, when we divide that by the atomic mass 16, we get the ratio as half, right? 1 is to 2. So the answer to that becomes 1. And for hydrogen, we get the simplest ratio as 2. Getting it? So this is how we get the ratio. I just want you all to please write this in your book. After this, the next thing that okay, so now ions, compounds composed of metals and non-metals, they contain charged species. Okay, and this charged species are known as ions, and this ions can consist of single charged atom or group of atom that have a net charge on them. And always remember that ion can be negatively or positively charged. Okay, so a negatively charged ion, we call that as anion, and the positively charged ion, they call them as cation. So take for example sodium chloride, and the example that we have is NaCl. Okay, so NaCl is the example of it, and always know that negatively charged ions are called as anions and positively charged ions are called as cations. Okay, got it everyone? So I just want you all to write about it and see. Let me just explain you till here. Then formula we can start it in the next part. See, ions it constitute particles are positively charged sodium ion, which we know it as Na plus, and they have negatively charged chloride ions, which we know it as Cl minus ions. So a group of atom carrying a charge is known as polyatomic ion. What it is known as? Polyatomic ion, because it is having many different atom having charges together, right? So we shall learn more about the formation of ion in chapter 4. And here we have some of the ionic compound along with the constituting element and the ratio by mass. So the ionic compound that we have is calcium oxide, and the constituting element in calcium oxide is calcium and oxygen, and it has been present in like in ratio by mass as 5 is to 2. Okay, then we have magnesium sulfide. So here it has been formed by constituting element as magnesium and sulfur, and that also is present in the ratio 3 is to 4. Okay, and then lastly we have sodium chloride, which has been formed by combining the different constituting elements called as sodium and chlorine, and the ratio by mass in which they are present is 23 is to 35.5. Getting it? So before writing this table, I want you all to write some of the points from here, and then we can start with the further part. Okay? So I hope everyone is dull till here at least. Then we have this like some atomic compounds which have been given, like the examples as calcium oxide, magnesium sulfide, and sodium chloride. So I just want you all to do that as well once. I hope everyone is writing this in your book. This is very important again. You should be knowing the ratio by mass, the constituent element with which the ionic compounds are been made up of. Okay. Now, after this, we will be discussing about writing the chemical formulae, and we will start with this in the next part, where we will be discussing on many different rules that we need to follow while we are writing any chemical formula. Then we will be discussing on formulae of simple compounds, okay, like how to write the formula of some of the simple compound, because we will be studying on the rule, so we will be like studying it with respect to some examples as well. Then after studying like this on how to write the formula, we will be discussing on molecular mass and mole concept in detail, right? So we'll do that, and then we'll discuss on formula unit mass, okay, what exactly formula unit mass is. Then we will discuss about mole concept in detail. It's not that we will just discuss on the you can say definition, we will be discussing that in detail. Then after discussing mole, we will be even discussing on relationship that exists between mole, Avogadro number, and mass. Okay, so we'll discuss that as well. And after this, after discussing about the relationship between mole, Avogadro number, and mass, we will be like discussing it with respect to many different examples, because we cannot do it directly, right? If we are studying it, we need to check on with certain examples how exactly it has been done. So we'll do that as well. So we have 3 4 examples for which of which have been given, right, as you can see on screen. So these are some of the questions, exercise examples that we will discuss, and then we have summary discussion like what exactly we have studied in the lesson about atoms and molecules. We'll summarize that in short, and after completing this, we have some of the exercise questions to discuss as well. So these are some of the exercise questions which I'm going to show you one by one, and I want each one of you to please go through this exercise question one by one. So this is how we are going to end up with the lesson atoms and molecules, and I hope whatever we have discussed so far in the lesson you're very much clear with it. Now the rest of the part for the lesson atoms and molecules, we will be studying that in the next part. Thank you everyone.